Hi everyone, welcome to the Earth Science Regents Review podcast series created by the Hommocks Middle School Earth Science Department. Today we're going to be talking a little bit about the solar system. Well, if you've been following in sequence, we started big with the universe and how the universe formed through the Big Bang. Next we moved down to the different types of galaxies and focused on the Milky Way. Now we're going to talk about the most important star in the Milky Way, our very own sun, and everything that moves around it. That's what we call our solar system. Scientists believe about 4.6 billion years ago, dust, gas, and rock left over from the Big Bang started to pull together through the force of gravity. That pulling together caused those rock fragments and dust fragments to collide together through the process of accretion. This was basically the very beginning stages, of the formation of our planets, including our own Earth, and the formation of the solar system as we know it. Well, in order to be part of the solar system, it has to move around the sun. That moving around the sun, that motion is what we call revolution. It's our orbit. Now, revolution is important because it gives us our seasons, months of the year, and it also takes us one trip around the sun in about 365 days. Do not get that mixed up with rotation. Rotation is going to give us day and night. So you have to be careful with the difference in motions. And what you're looking at now, that's rotation. What you're looking at now, that's revolution. Mercury, Venus, Earth, and Mars all revolving around the sun, and including the asteroid belt. Now, our solar system really focuses on the sun and the 8 planets. The 4 terrestrial planets, Mercury, Venus, Earth, and Mars, and the 4 Jovian planets, Jupiter, Saturn, Uranus, and Neptune. Now, this picture is not only going to show you the 8 planets, but many of the moons and some of what we call the dwarf planets, which includes Pluto, that are found in the solar system. Now, this picture is going to show us 88 total objects, and you're going to see why Pluto is declassified, because many of these objects we'd have to include into the solar system model if we kept Pluto a planet. So here we go. So there's the 4 Jovian planets. Now we're going to go into some of the terrestrial planets here. And this is going based upon, in order based upon diameter, equatorial diameter. So you can see how many objects have actually been documented with at least a diameter of 200 miles. A lot of objects. Now, the solar system model that we use today was not what was used in the past. The first model that was proposed by Ptolemy, and this is the geocentric model. During Ptolemy's time, there was no solar system, there was no galaxy, it was just a universe. Ptolemy couldn't feel the Earth move, noticed everything rose in the east and set in the west, so we must be the center of everything. That's your geocentric model, or Earth-centered model. Geo means Earth, centric means center, Earth-centered model. Well, it wasn't until about Copernicus came around, and Copernicus proposed the heliocentric model, which is the model that we use today. Helio means sun, centric means center, sun-centered model. And that's obviously the model that we are talking about right now. Okay? Don't forget about page 15 in your reference table. You have every category that you need about every planet that we have in the solar system. Make sure you know how to use this. Page 15 in the reference table. Okay? That's it for now.